get 0.000. No, we don't have that. What's this? No people in the group of 7 have the same birthday. Oh, this is, no, this is, wait a second. Approximate probability. No people in the group of 7 have the same birthday. And these are 7, right? 1, 2, 7, so 365. 7, 2, 3, 6, 9, do this. How on earth did I do something wrong? 364 times 363 times 362 times 361 times 360 times 359 divided by 365 equals 6. What did I get? Oh, okay, I'm sorry. This is a permutation, not, oh my God, how did I do that? This is permutation of 365 taken 7, not the combination. So I should have done the following. So 365, you get probability NPR 7. And then you divide that by 365 to the 7, and you get 0.9437. Which in this case is the 0.94. I will post both answer and the solution. Yeah, if it were a combination, I would have divided by 7 factorial. I just did my little combination. But as I said, if you keep multiplying those and dividing by those, you get that answer. Okay, the second question gives you 12 data points and asks you to find the mean. So really, you don't need a calculator for that. You just add them up and divide by 12. So we have. Can someone tell me why this thing is not working? Yeah, but still not that great, but so you see the numbers here. We have 12 numbers. Again, you can use your calculator. You can use, or you just add them up and divide by 12. If I'm going to use my calculator, most likely I will create the list. If I need, so I will go to data and then enter them 3, 4, 4, 5, 8, 10, 11, 15, 18, and 20. And once you have those, I enter the 12 values here. Okay, I will exit. Wait, and then go to stat. It will ask me how many variables. I say I have only one variable. Yes, 1. Calculate. And once you calculate, it gives you the number of data points, x bar, the standard deviation of the sample, the standard deviation of the population, and everything. And sure enough, the mean is 9.5, which is B in this case. So x bar. Did I take all the answers on purpose? The summation of the x sub i's over n equals 3 plus 4 plus 15. 20 was the last one, over 12 equals 9.5, which is the The third question says, a study gives the following results for a total sample size of 8. So I have a sample of size 8, and they ask you to find, and they said the mean is 7.25. What is most nearly the standard deviation? Well, you know the equation for, let me write it here, the equation for the standard deviation, first of all, for the variance, is the summation of the difference between all the x sub i's minus x bar on n squared over. Here, remember, here they said, what is most nearly the standard deviation? When they don't say the standard deviation of the sample, it means the standard deviation of the population. So you divide by n. If it's for the sample, so this would not be, I'm sorry, that would not be s squared, that would be sigma squared. If you want s squared, so this is variance of the population. The variance of the sample is the summation of x sub I minus x bar on a t squared for all I over n minus 1. And because they didn't say of the sample, then it means I want the variance of the population. And they give you the second point, 7.25 as the mean, so that you can subtract. I hate that. Why? Because when the mean is not integer, all your subtractions would be fractional. And then you are going to square them. That will become even worse. There is another shortcut for that says, you know, instead of writing that, there is a shortcut that says it's the summation of x sub I squared for all I minus the summation of x sub I for all I squared over n, or the same thing over n minus 1, same numerator. This is much easier. Look at that, look at how we are going. If I, again, you can do the variance with your calculator, right? I don't know why they give you the mean. Aren't you going to use your calculator to do that? So like I did, see here when I enter these values in my calculator, so if I go and say, if I go to data and then just delete those, and enter the 8 values, I'm going to solve it 2 different ways. So I'm going to enter 2, 3, 5, 8, 8, 10, 10, and 12. And then I'm going to exit. And then I'm going to do stat, 1 variable, calculate. And you can see it gives you, you had 8 points. It gives you the 725, which they gave you as the mean. It gives you the variance of the sample. That's not what we are looking for. We are looking for the variance. I'm sorry, that's the standard deviation, not the variance. They ask for the standard deviation. They don't ask for that. They ask for the standard deviation of the population, which is sigma x naught sx, 3.34. 3.3 is the answer here. So that's one way to do it. I mean, you don't really need the calculator. I'm sorry, you don't need the mean. But if I notice that if I wanted to do that using this approach, not by subtracting 7 1/4 and squaring, that's ridiculous, right? I could have said 2 squared, 3 squared, 5 squared, 8 squared, 8 squared, 10 squared, 10 squared, and 12 squared, and simply add the log. So you get 13, 18, 22, 26, 30, and you get, what, 15, 17, 19, let's see, 4, 9, 25, so that's, okay, 128, 38, that's 164, no, that's not correct. missed that. So 13, 18, 22, no, it's correct. Right? Yeah. Okay, or you simply add them all in your calculator. Just make sure I didn't mess up. 4 plus 9 plus 25 plus 128 plus 344. Yeah, I really didn't type. Okay, 25 plus 64 plus 4. It's 510. Yeah, could it be only 400? These already are 180, so it's 510. The sum of the values, 5, 10, 18, 26, 36, 46, 58, the sum of x is 58, right? So now if I say 510 minus 58 squared over 8, because there are 8 points, so if I say 510 minus 58 squared over 10, it will give you 173.6. You divide that by n again, you will get the variance. You take the square root of that, so you raise it to the power of 0.5. Yep. I'm losing my mind. What on earth is that? I can add. You know this calculator, sometimes I push the buttons and yeah, that's 510. And then we said 3240, 58. That's correct. So 510 minus 58 squared over, oh, I divided by 10, there are only 8 points. Why did I divide by 10? Nobody told me. Okay. And then you divide by 8 again, and then you take the square root, not to the power of 5. What? Oh, the point didn't show up again. 3, 3, 4. Oh my God. Sorry, guys. 3, 3 was a long day today. So, 3, 3, 4, as we got with the calculator again, I just wanted to show you that this equation works. It's usually easier than to subtract the mean every time and square and add. But if you are using your calculator, you really don't worry about that. So the 3, they wanted sigma, which is the square root of the summation over all possible values of I of x sub I minus x bar squared over n minus 1. Or, as I told you, you can do it as, oh, I'm sorry, over n. That's sigma, not s. The square root of the summation over all possible values of I of x sub I squared minus the summation over all possible values of I of x sub I quantity square over n. Usually that will be easier because, especially if the individual data points are integer, like most likely they will give you in the test. So the squares and the summations of everything would be integer, except at the end you can use the calculator like we did here. So 510 minus 58 squared over 8, which are the sample size, and then over 8 again, and again. If that was an S, meaning if they ask you to find the standard deviation of the sample, all what you have to do is to change the n into n minus 1. Because the sample standard deviation, we say it's an unbiased estimate, it's a biased estimator of the population standard deviation, which really sometimes we cover that now, or in more advanced statistics course. Okay, any questions so far? It's not clear. Problem Problem number 4, same thing. They tell you a study gives the following results for a total sample size of size 6. So give you 6 data points. They ask you the mean of the sample is 13, again, because they want you to subtract and square, which you can do. What is the most nearly the sample standard deviation? So you will divide by n minus 1. Again, I can do it right away with my calculator. I don't need someone to tell me what the mean is or whatever. I can go to data. I cleared everything in the memory. So I will enter 10, 12, 13, 14, 14, 15, and then exit and say, give me the stats. The mean is 13. And the standard deviation is 1.78, which is 1.8 d. So that's the first method you can do it. Or you can square the numbers like we did here. So we can say it's the sum, 6 values. So what do we have here? 100. 144, 169, 196, 196, 225. What is the sum of those? 22, 35, 50, 70, 1.788, the same result, which is 1.8 over d. So this part, what did we get last time? I can't remember. Didn't I save that? No, probably not. So it's 3.34, which is roughly 3.3 part C. And then in 4, they ask you to find S, which is square root the summation of x of I squared minus summation of x of I quantity square over n minus 1 equals 1.788, which is roughly 1.8, and that's D. Okay, that's number 5. I mean, why do they have too many questions on the same topic? Doesn't make sense. Okay, in problem 5, they said a study has a sample of size 5, a standard deviation of 10.4, and a sample standard deviation of 11.6. What is most nearly the variance? I don't know why they give the sample size, but they give you the standard deviation and the sample standard deviation. Right? If they didn't say sample, they mean the whole population. And since in the variance they ask you, what is the variance? They never said this, the sample variance. It means just take the standard deviation and square it. If you square 10.4, you will get, what, 108.16? Right? So what is next to that? So the variance is sigma squared, it's 10.4 squared, it's 108.16, and then (110) is the closest, so it's okay. So that's about finding the mean, the standard deviation, the stuff. These are the first 5 questions. Okay, let's move to the next one. There are numbers in here. So question for problem number 6 says a study. Oh no, we did 7. We need 7. Already did 6. No, it's 6. Oh my god. So I read a study, so I thought that's the one we already did. We start the same way. But this is a study that has a sample of size 9, a standard deviation of 4, sample standard deviation of 4.2. What is nearly the sample variance, S squared? So here you say S squared equals the sample standard deviation squared, right? Because they tell you that the standard deviation is 4, but the sample standard deviation is 4.2, right? So it's 4.2 squared. It's what? 1764. So 18 is the closest, so that would be B. They're still in the mean of the standard deviation. Oh my god. Okay, so problem number 7 goes to probability. They say we have a bag that contains 100 balls and they are numbered 1 to 100. One ball is drawn from the bag, just one. What is the probability that the number on the ball, on the ball selected will be odd or greater than 80?
Greater than 80 or 80?
80. I don't want you to count them. You can, right? You can. But if you want to use, because these numbers may be different and tough, so the best way is to use probability. Anyone knows what's the meaning of odd or? What is the or?
That's addition.
That's what I want to hear because it's not correct. No. I'm not blaming. No. This is a common mistake. Remember when I said a while ago that the and in the first problem, we said the and we multiply, we make it times. I can't do that unless the events are independent. Only when they are independent, I can say the and becomes times. There is something similar to that. The or becomes plus only if the events are mutually exclusive. What's that mean? Ask yourself the question. What is the first event? The first event is you get an odd number. The second event is that it's greater than 80. Can I have a number that is odd and greater than 80? Yeah, so they are not mutually exclusive. So I cannot say the probability of A plus the probability of B. What do I have to say? What is the probability of A or B? The law of addition in probability, what is that? if they are not mutually exclusive. Notice if I draw a Venn diagram, can I say here is A, here is B, and they are mutually exclusive. So if I say A or B, of course, it's a sum of them. But if they aren't, if this is A and this is B, if I say the probability of A, I took this whole area. And then if I say plus the probability of B, then I took that whole area. Notice what happened? The intersection has been counted twice. So what do? I subtract the interaction. If they are not mutually exclusive, you have to subtract the intersection. If they are mutually exclusive, then it's A plus B, yes. Because that becomes 0, right? What is the probability that you get both A and B? It's impossible. How can I get them both if they don't share anything? And then the key thing here. So notice what we did to see if they were mutually exclusive or not. We said, can both happen simultaneously? If yes, they are not mutually exclusive. There is a different question. There is a different question that I can check to see if they are independent or not. Are these two events independent or not? What do you ask to know whether they are independent or not? You know the meaning of independent? They have nothing to do with each other. So in other words, just to give you some funny thing, I'm going to toss a coin and ask you, what is the probability that I will get a head? 0.5, right? Okay. And then say, oh my God, no, wait a second. While I was tossing the coin, I drew a card from a deck of cards and I got a heart. I forgot to tell you that. What is the likelihood of getting a head? Still 0.5. Are you crazy? They have nothing to do with each other. The outcome of one doesn't affect the outcome of the other. So I'm going to ask the question. I'm going to get in a ball. What is the likelihood that it's greater than 80?
You're not down 80, right?
No, greater. They said greater than 80. No. Wait a second. I'm asking a simple. Okay, let me ask you a different question. I'm going to select a ball at random out of these 100. What is the likelihood it's odd? As an odd number. 0.5, right? And then I say, oh my God, I forgot. No. I selected the ball and it was greater than 80. What is the likelihood that it's odd?
If it's greater than 80
No. I didn't say that. I said, like the first example when I told you I picked a card and it was hard. I'm asking if I select a ball at random, what is the probability that it's an odd number? It has an odd number. It's 50%, 0.5, right? Now I'm saying, I forgot to tell you that the number I got was greater than 80. It wasn't 80 or less, it was greater than 80. What is the likelihood it's odd? It's still 0.5. There are 20 numbers above 80. 10 of them are odd, and 10 of them are even. So it's the same, meaning they are independent. If you know the outcome of one, it doesn't change the probability of the other. You see the difference between mutually exclusive and independent? So these are not mutually exclusive, but they are independent. Because the probability of getting an odd number is 0.5. The probability that it's above 80, it's still 0.5 to be odd. So now I would say, oh, so this is the probability of A and B. But because A and B are independent, the and becomes times. So now I'm going to say, this thing is the probability of A plus the probability of B minus the probability of A times the probability of B. Because of independence, only because of that. What is the probability of A? A is picking a number that is up. For example, what is that probability? We said it's 0.5. What is the probability that I select a number that is greater than 80? How many numbers are greater than 80 in 100? 20. So the probability would be 0.2, right? Minus 0.5 times 0.2. So it's 0.5 plus 0.2 minus 0.1 equals 0.6. That's how we solve it. So probability of A equals 0.5. Probability of B equals 0.2. A and B are independent. This is a key word here. So when I say the probability of A or B, which generally is the probability of A plus the probability of B minus the probability of A and B, because of independence, this guy is simplified as the probability of A times the probability of B. If and only if they are independent. If they aren't independent, you cannot do that. You cannot say that. So that becomes 0.5 plus 0.2 minus 0.5 times 0.2 equals 0.6. And sure enough, that's C. This is an important one because it draws on many. They definitely will have to have the 0.7 as one of the solutions because they are expecting you to say, oh, 0.5 and plus 0.2 is 0.7. Okay, so be careful. Okay, number 8. Measurements of the water content of soil from a borrow site are normally distributed with a mean of 14.2. So now we have normally distributed data. Mu is 14.2%. Sigma is 2.3%. Okay? Meaning, you know the normal distribution, or we call it sometimes the Gaussian distribution, looks like that. And we say the mean here is 14.2, and the standard deviation, which is the distance from the mean to the inflection point, is 2.3. They ask you, this is the second page. What is the probability that a sample taken from the site will have a water content above 16% or below 12%? The 16 would be somewhere here. Above 16 or below 12. So how do we do that? Using a table. The normal probability table. Notice that in the old days before computers, we had to rely on tables. So if I go to a statistician and I say, oh, can you please give me a table, construct a table for a normal distribution whose mean is 14.2 and a standard deviation of 2.3, how long it's going to take them to do that with knowing that there is no closed form solution to that integral of the function of the normal distribution? They have to use numerical methods without a computer, without a calculator. If they don't shoot you, then, and you survive, and then you come the following day and say, can you do another one with a mean of 13 and a standard deviation of 3.5? Eventually they will shoot you, right? So there is no way. So statistician, in order to get done with that, you know, all mathematicians, unlike anyone here is a dual major with math, you know, so I can freely talk about mathematicians. My daughter has a master's in pure math, but I can't talk in front of her. So mathematicians, unlike us, mortal humans, they have the, their brain cells are connected differently. So what will happen? They said, you know what? I have a great idea. Whatever your normal distribution is, change it, make the mean equal 0 and the standard deviation equal 1. You say, huh? What do you mean? He said, oh my God, I forgot you're not a mathematician. Okay, so in order to make the mean 0, take every number you have in your problem and subtract 14.2 from it, okay? Did you get it, non-mathematician? Yeah, okay, I'm going to subtract everything. I'm going to subtract 14.2. But what do I do about this inflated standard? It's 2.3. See, divide the numbers that result by 2.3. Then you create a new one whose mean is 0 and its standard deviation is 1. And we are going to call that the standard normal distribution. And I will create a table for that, and I don't want to hear from you again. Okay? So that's exactly what they did. There was a joke about two mathematicians who went to a restaurant, and then they were arguing, if the layman is good in math or not. So one was saying, yeah, I think they are decent. And they said, I doubt it. They don't know anything about math. They just learn it in school and then they forget it. They are losers. He said, okay, we can have a bet. So while the guy who doesn't think highly about us had to go to the bathroom, the other mathematician grabbed the chance and called the waitress and told her, I want to ask you a question. She said, yes, sir. He said, in 5 minutes I'm going to call you, and then I'm going to tell you, I will ask you a question, and all what I want you to say is 1/3 x cubed. And she said, 1/3 x cubed? He said, no, 1/3 x cubed. Can you do that? She said, I think I can. So she left. The other guy came back and he said, oh, are you ready for the bet? He said, sure. So he called her and he said, lady, can you please tell us what is the integral of x squared dx? She said, that's easy. It's 1/3 x cubed. And then she left. He turned and started smiling to his friend, and then the waiter stopped and she said, I'm sorry, plus a constant. So anyway, my daughter hates me when I say things. Bad jokes. So that's what we are going to do. We are going to say, okay, if you want something below 12, I'm going to standardize the 12. We call it standardization because I want to take this 12 and place it here. If you come to think about it, we are saying so here the steps were units, right? And because the standard deviation here is a unit, now the steps here are in standard deviations. So I'm saying, how many standard deviations are you below the 0? And you say, well, if the standard deviation is 2.3 and this is 2.2, then I am 2.2 over 2.3 steps to the left of the 0. Meaning, if I standardize that, this would be 12 negative 2.2 over 2.3. And the 16, which is 1.8 above, it would be 1.8. Oh, I'm sorry, it should be somewhere. It doesn't matter, it's not to scale. So I'm going to use my calculator and say, what is, okay, let me clear it. I said reset everything, okay. So what is negative 2.2 over 2.3? I get, this is negative 0.96, and 1.8 over 2.3 is 0.78. So I need the area to the right of 0.78 or to the left of negative 9.96. So now you can use the tables for the normal distribution. Here is the normal distribution. Yeah, this is the T. Notice that the normal distribution gives you many headings. What are these headings? The first one says f of x, meaning the height here, which you will most likely never use unless they ask you what is f of x at that point. It gives you the cumulative of x, meaning the area from negative infinity up to the value n. It gives you the reliability of x, which is the complement of that. It's the area to the right of x. And then it gives you also, if you have the same number, like if this is like 1.5 and negative 1.5, it just, instead of calculating 1 and multiply it by 2 because of symmetry, it just multiplies it by 2 for you, and then it gives you the complement of that. What's between plus or minus? We know that between plus or minus 1 sigma, you get roughly 68.3% of the distribution, and you get at 1, yes, it is 68.3. If it's 2 sigma, it's 95.5. If it's 3 sigma, it's 99.27. So all of these. So what we are looking at for the negative 0.96, again here there is no negative 0.96, so the best you can do is to go to the closest, which is 1. We don't interpolate. It's not even going, yeah, it would be closer to the true answer, not correct, because that's a curve, it's not a linear line anyway. So if you go to negative 1 and you want the area, notice that if it's 1, the area to the right of 1 is the same as the area to the left of negative 1 from symmetry, right? So I can go to 1 and get the reliability of x, meaning the area to the right of x, and it's 0.1587. So I say this area is 0.1587, right? Yeah. And then the other one is 0.78. No, I'm sorry. Yeah, I wanted, yeah. And then the other one is 0.78, and again, since we are going, I'll go to 0.8. I want the area to the right of that, which is 0.2119. And then I add them up. .3706, right? Number 8, 0.37 is C, so it's still C. Okay, does that make sense? Any questions on that? I did the review of statics before, twice, and strength of material also twice. As I said, my undergraduate was civil, so it was nice. I also, back in Kentucky, I did calculus, and I did engineering economics, which I usually teach with Professor Riley. We split for someone. I taught it in the fall, he teaches in the spring. I think you are going to change your catalog. This last time we were discussing that with the curriculum committee. It won't affect you. It's just they are going to move the engineering economics to be in the fall instead of spring. They would recommend it for doing the fall instead of the spring. So now we have 1 sections in the fall and 2 in the spring. They will be reversed between the fall. Doesn't matter. Okay. What is the probability that either exactly 2 heads or exactly 3 heads will be thrown if 6 fair coins are tossed at once. How would you solve that? What distribution gives that? It's called what? Who knows? It's called the binomial distribution. The binomial distribution is basically that tells you if you have an experiment that has only 2 possible outcomes, we call that the Bernoulli trial, and you repeat it n independent times. Notice if I'm going to toss 6 coins, if the first comes out to be a head, it doesn't affect the second being a head, right? They are independent. So the binomial distribution, which again you don't need to know what the probability of x is, but it is, and where n is the number of trials, p is the probability of success, 1 minus p is the probability of failure, since there is only 2 possible outcomes. Something very interesting in tossing coins. The probability is 0.5 of success, and the probability of failure is also 0.5, which makes it the worst thing to predict. I'm not going to elaborate on that. But I'm going to toss it 6 times. What is the likelihood that I get 2 successes? This guy is 0.5 raised to the x, and this guy is 0.5 raised to the n minus x. You see why 0.5 is so easy? Because it doesn't matter what numbers, they will always add up to 6. So it's as if you are saying, what is 1/2 to the 6? It's 1 over 64. And then you take 6 take 2. What is 6 take 2? How do you do the combination? Again, we can do that with the table. I mean, I'm just telling you that for the coin, you really don't need any of that. How many of you heard of Pascal triangle? This is my best, toy. Here is the Pascal triangle. I love it for many reasons, but we call the first row the 0th row, the second row the first row already, the third line would be the second. So we ignore the first entry because it's always a 1, and then read next. Nothing here, so it's 0, here it's 1, 2, 3, 4, 5, 6. Notice I ran the experiment 6 times. So I'm going to look at this line. If you add those, by the way, you will get 64 to the end, always. So the 64 here is just the sum of them. You know what? The probability of getting no heads and 6 tails is 1 over 64. The probability of getting 1 head and 5 tails is 6 over 64. 2 heads and 3 heads. So if you want 2 or 3, notice 2 or 3, can you get 2 and 3 simultaneously? So you toss 6 coins, you get, oh, we got 2 heads. Oh, and 3 heads. Oh my God, that's great. Can that happen? No, it's impossible, right? So they are mutually exclusive. So the or becomes plus. I can add 15 plus 20 is 35. That's how simple the answer is. It's 35 over 64. Notice, please be careful, that only works 0.5468, which is B, 0.55. This only works if the probability of success is 0.5. If it's something else, of course, that won't work. And this, by the way, it also gives you the combinations, because that's 6 take 0, 6 take 1, 6 take 2, 6 take 3, and you can do it for any number. However, if either the probability is not 0.5, or you want just to make sure you are getting it correctly, here, this table, you have to be careful with this table, because that table gives, it's a cumulative binomial distribution. What's the meaning of cumulative? So if I want the cumulative of 3, it will give me the probability of getting 0, or 1, or 2, or 3. And then if I say, okay, what is the cumulative of 2? It will give me 0, or 1, or 2. So if I want both 2 and 3, I can say it's the cumulative of 3 minus the cumulative of 1. Because the cumulative of 3 would give me 0, 1, 2, 3. The cumulative of 1, when I subtract it, it will take away the 0 and the 1 and leave me the 2 and the 3. So another way of doing it is just to go to the column of 0.5, which is the probability of getting a head or a tail. And this is problem 9. Okay, I get the cumulative of 3 when you have six tries. So here is 6, 0, 1, 2, 3, 4. I go to the 3 and I read 0.6563. That's the cumulative of 3. And then I'm going to subtract the cumulative of 1. And the cumulative of 1 is 0.1094. .5469, we got 0.54687, because that, of course, is more accurate, but the answer what? 54, so it's 55B. Okay, did you understand that? So usually this works if the probability is not 0.5. So if it's 0.5, really it doesn't take you long to construct the Pascal triangle, and it's so easy. Another thing I like in Pascal triangles is that if you go along this diagonal and you keep adding 2 consecutive numbers, you get the squares. You get 1 or 4 or 9 or 16 or 25 and so on and so forth. Not only that, if you add diagonally, meaning I do 1, 1, 2, 3, 5, 8. Where is the? It's because here I have the one. Oh, this one. Right? Yeah. You get 13, and keep going. What do you end up having? So if you go sideways and then you either read or watch the Da Vinci Code, what do you get? You don't know this series? 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. No, really? Fibonacci. It's called the Fibonacci series. You know what the Fibonacci series was? They tell you it's in biology. They say, okay, if you have an organism, that organism, when it's born, it's like it's just one. It takes 1 day to mature, become an adult. And once it's adult, it can give birth. So in the first day, you start with 1 guy. The second day, that one becomes an adult. And the next day, we'll give birth to another. We can do that in a different color when it's adult. So there are 2. The following day, this will give birth because it keeps doing that, but this guy will become adult. The next day, they both will be adult, and the third one will also be adult, but only the first two will give birth. It's the 1, 1, 2, 3, 5, where every entry is the sum of the previous two. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 8, 13, 21, and so on and so forth. What's embedded in the Fibonacci series, which is really, 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 really good, and as civil engineers, you understand what I'm saying here. If you divide every two numbers by themselves, so 1 over 1 is 1, that's the lower limit. And then 2 by 1 is 2, that's the upper limit. And then 3 by 2 is 1.5. And then 5 by 3 is 1.67. And then 8 by 5 is 1.6. And then 13 by 8 is 1.625. Do you see where I'm heading? Did you recognize the number? Where will I end up having? What am I going to have if I keep going until infinity?
The square root of pi.
No, it's not the square root of pi, but it's another very common number. The golden ratio. Ever read about the golden ratio? It's everywhere in nature. It's in the Roman temples, in the statues, and many things. It's.
I don't remember the number, but I've like heard of it and stuff.
Okay, the number is so easy. So easy, it's the only number in the world that if you take its reciprocal, the difference would be 1. So if you solve this equation, you will get x squared minus x equal or plus minus 1 equals 0. And then you think, what are you going to get? Root of 5 plus 1 over 2. Square root of 5 plus 1 over 2. I'm sorry. Now, if you say 1 over that, look at what happens when I take the reciprocal of that. Oh my God. X minus 1. It's as if you subtracted 1. The number and its reciprocal differ by 1. It's the only number in the book. And we call that the golden ratio.
How is it used in the Roman statues?
You see when they have the, if you open your arms, I think the distance over the height of the statues is always 1.6. Or the other, if you can say no, the height of the statue over that distance is 0.61, whatever. So it's the reciprocal of it. And the funny thing is that it doesn't matter because if you take the reciprocal, you get the other one. So the ratio can be 1.6 or 0.6 if you reverse the distance. Anyways, I wasted your time. There are many other stuff, by the way, embedded in that Pascal triangle. It's so amazing. Okay. That's number 9. So if we go to 10, what do we have? Which of the following statements about probability is not valid? The probability of an event is always positive and between the range of 0 and 1. Is that true or false? Probability is always between 0 and 1, and it's always positive, cannot be negative. The probability of an event which cannot occur in the population being examined is 0. Yes or no? True, of course. It's like, I'm gonna roll a die. What's the probability that I'll get a 9? Oh yeah, be my guess. If you are, if you are drunk, you may. I'm not sure about that, right? If events A and B are mutually exclusive, they cannot occur together, then the probability of either event occurring in the same population is 0. Right or wrong? True or false?
False.
False.
Because the ball is.
They didn't say both occurring. They said the probability that one of them, one event occurring in the same population is 0. Why? Only one occurring, not both. If they are mutually exclusive, they cannot happen both. Like when we tossed the coins, we couldn't get 2 heads and 3 heads at the same time. But you can get 2, you can get 3. Just one event, yes. The probability of either event occurring, not both. If they say both event occurring is 0, yes, that would be true. This is the only false. And then they say the probability of either of 2 events, A and B, occurring is probability of A plus B, probability of A plus B minus the inner section, which is correct. And you say, what if they are mutually exclusive? It doesn't matter. This guy will be 0. So you will end up with B, A plus B. So C is false. This is just C. Okay, you move to 11. 11 says you are playing a game. You have a fair die used in a dice game. A player wins $10 if he rolls either a 1 or a 6. He loses $5 if he rolls any other number. What is the expected winning for one roll of the die? Another word for expected value is the mean. What is the mean or the expected value? How do we calculate it for any function of x, where x is a number 1 through 6? If you remember from Mao, if we have a discrete distribution like that, discrete meaning you can get either 1, 2, 3, 4, 5, or 6, nothing else. You can get 2.4, for example, with your roll die, right? So we say the expected value of anything, I'm going to place here a star. And this star is a function of x. It may be x. It may be x, or it may be a function of x. It may be sine x. It may be e to the x. It may be x cubed minus 4x plus 5. Anything. Anything. Then I can replace this thing with the summation over all possible values of I of this function sub I times the probability of x sub I. That's how simple it is to do any function. So let's think what we have here. What we have are 6 values. And then they say, if you get a 1, that's a positive $10. If you get a 2, that's a negative $5. A negative 5, a negative 5, a negative 5, a positive 10. Right? 1 or 6, you get $10. Anything else, you lose $5. In fact, right there you can see the answer. But the probability of getting a 1, which is the p of x, notice this is a function of x. If I get a 1, somebody's telling me you're getting 10. So that's, if you know x, you will get the outcome. So that's a function of x. Each one of those is 1/6. So if I sum this row times that row, I will get, forget about the 6, you get 10 minus 5 minus 5 minus 5 minus 5 plus 10 over 6. It's 0 over 6, it's 0. It's a fair game. Because there is only 1/3 probability that you win and 2/3 that you lose. But your winning is twice as much as the loss. So it's a fair game. Or you can pick any two and make them $100 and the loss is $50, whatever. But you make sure that the product gives 0, and that would be the answer here. The answer is 0, which is A. By the way, if the x is continuous, I don't think you will get a continuous here. That would be the integral from negative infinity to plus infinity of that thing times f of x dx. So if I want, so if this is x, and I tell you, I'm going to roll a die, what's the expected value of x? You multiply each number by 1/6. It's like you add them up and then divide by 6. When you add them up, what do you get? 21. You know how to add series? Series that increases by 1. That's so easy, right? If you start from 1, and I say, what's 1 plus 2 plus 3 till 60? What would that be? No, if it took so long, please, you don't know what to do. It's so easy. X times x plus 1 over 2. Right? So here I'm going to say 6 times 7 over 2. Or 3 times 7, or 21. So the sum of these is 21. Divide 21 by 6, you get 3.5. And you say, but if I roll a die, how can I get 3.5? I didn't say you will get 3.5. We say this is the expected value. And again, it has, think about it since you did IA, right, a long time ago, as the centroid. So you have, notice they have the same weight. So you have six masses that have the same weight. And then you place one at a distance of 1, and one at the distance of 2, and one at 3, one at 4, one at 5, one at 6. Where would be the centroid? And you say, oh, the way we learned it is that we take the moment about the origin and say 1 times 1 plus 2 times 1 plus 3 times 1, well, that's the 21. But we didn't, and then notice that we didn't multiply the weight by the distance. So it's like I'm going to multiply 1/6 by 1 plus 2 plus 3 plus 4 plus 5 plus 6. So I get 21 over 6. But then we divide it by the total weight. Guess what? The total weight will always be 1, so you don't need to divide by anything. The funny thing is that the mean is called the first moment about the origin. It is the first moment about the origin. I'm going to give you the definition of the variance of a population and ask you the $64,000 question. The definition of the variance, you saw what we did with the variance of a sample, but for the population. Its definition is the second moment about the mean. What do you call that? What did you call it in strength? The second moment about the mean. The what of inertia? The moment of inertia. Yes. The variance is the moment of inertia. So if I consider these to be distances, and the mean is at 3.5, and tell you, take the second moment about 3.5, you definitely will get the variance of that. And then, remember, when we divide the variance I'm sorry, when we divide the moment of inertia by the mass here is 1, so it's like you divide it by 1, okay? And then take the square root. What do we call the answer? The quantity that is the moment of inertia divided by the area of the mass, because you can do it for mass or area, and then you take the square root. What do we call that? Start with an R. 3 words. Starts with an R. The middle word is of. The third last word starts with a G.
Radius of, no, that's not the radius of gyration, that's not it.
What?
Radius of gyration.
It is the radius of gyration. That's the standard deviation, believe it or not. And many statisticians don't know that because they cannot relate with engineering or whatever. That's a discussion for another day. A simulation model for a transportation system is run for 30 replications. And the mean percentage utilization of the transporter used by the system is recorded to form a confidence interval on the mean transporter unit utilization for the system. So I construct a 95% confidence level, and the confidence interval is found to be this plus or minus 3.4%. They ask you a few questions. Which one, given this information, which of the following facts can be definitely stated about the system? Which one is correct? Read them. I know they are, if you are sitting in the back. The first one says, at 95% confidence, the sample mean of transporter utilization lies in the range 37.2% plus or minus 3.4%. True or false? Write down. The sample functions are constant, are deterministic. If I give you a bunch of numbers and I ask you for the mean or the standard deviation or the mode or the variance or whatever, you will end up with a single number, right? There is no probability in it. If it's for a sample, then I cannot say it's, oh, here are the numbers and the mean is 9 plus or minus, give or take 1. No, it's a specific value, so the first one is incorrect. The second one said at 95% confidence, the population mean, yes, that's the population mean of transporter utilization, lies in the range 37.2 plus or minus 3.4. This is the correct one. Let's look at the third one. The third one says at 95% confidence, the population mean lies outside of the range. No, I give you the range in which the mean is. So. And then the last one says that 5%, the mean lies inside of that. No, it's not. It's 95, not 5. So that's a B. Of course, there's nothing to write here, but say 12. Already 7? Sorry, missed. Okay, so let's do this quickly. What is the approximate probability of exactly 2 people in a group of 7 having a birthday on April 15th? I know you're not statisticians, but again, this is exactly the same problem of 2 heads or 3 heads when we threw it 6 times. It's as if, notice I'm going to give you a different problem, but it's solved exactly the same way. I'm going to toss 7 coins, but my coins are biased. They have a probability of success of what do you think? What do you think the probability of success here be? 1 over 365 is the probability of success. what is the probability that I get 2 successes if I toss this coin 7 times? That must be a very small probability, right? Because there is 1 in 365 chances, and you are only going to toss it 7 times, and you want 2 successes? Okay, so you cannot do it with the table, because the table will not give you 1 over 365. You have to do it the way we did it earlier. Remember when we said 6 take 2? Here I'm going to say 7 take 2, but now instead of saying 0.5, I'm going to say 1 over 365 squared times 364 over 365 to the 5th. And you say, why do you have the 7 take 2? Does it make sense to say, the first, we have 2 people, and each one, in order to be a success, in order to be born on 15th of April, is 1 over 365. And 5 failures, and the probability of failure. So why do you have 7 take 2? You know why? Because I have 21 different combinations. I can have the first and the second being born on the 15th, or the first and the third, or the first and the fourth, or the first and the fifth, or the first and the sixth, or the first and the 7th, or the 2 and the third, 2, 4, 2, 5th, 2, 6, 2, 7th, 3, 4, 3, 5, 3, 6, 3, 7, 4, 5, 4, 6, 4, 7, 5, 6, 5, 7, and 6, 7. These are the 21. That's the 7 take 2. And then you use your calculator. You can do 7 take 2, you know, it's 21 times 364 to the 5th divided by 365 to the 7th. Oh, I didn't. What happened? Divide, why did I say? Yeah. I'm sorry. Let's do that. Clear. Okay. 21 divided by, or times. We have 364 over 365 to the 5th, and then you divide by 365 to the 7th. 0.0001 7 take 2, 1 over 365 squared, 364 over 365 to the 5th equals 0.000155. So D is 1.6 to the 10 time to the negative 4. That's D. Number 14. What are the arithmetic mean and sample standard deviation of the following numbers? Use your calculator. It's the easiest thing. So I'm going to go to data and enter these values. 71.3, 74, 74 and a quarter, 70, 78, 54, and 80.6. Exit, take the stat, one variable. It gives me the mean is 75.7 and the standard deviation is 375. So 75.7 and 375 is D. You don't need really. Four coins are tossed at once. What is the probability of obtaining 3 heads and 1 tail? If you do the Pascal triangle and go to row 4, because we are going to do it 4 times. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. 3 heads and 1 tail, or 3 tails and 1 head, it doesn't matter. 0, 1, 2, 3, or 0, 1, 2, 3. It's 4 divided by 2 to the 4th, right? Because that's the rule of 4, they add up to 16. 4 over 16 is 0.25, which is 8. You really don't need, you can do that, you can come here and say, but then if you are going to use that, you say, I'm going to run it 4 times and I want 3 heads. So I have to take the cumulative of 3, but then I have to subtract the cumulative of 2, right? Because 3 or less minus 2 or less would leave you with only 3. And you can see the 7, 5 and the 7, 5 would cancel, and this minus that is exactly 0.25. But as I said, when it's a coin, it's easy to do Pascal triangle quickly. Okay, number 16. Unfortunately, my stick. I'm sorry to keep you. It's just I didn't realize that these problems would take that long. Okay, set A and B are subsets of universal set U. So U has values from 4 to 10. Let me write them down. So U is 4 through 10. A, it's 4, 7, 9. B, B is 4, 5, 9, and 10. What is the union of the complement of set A with set B? Meaning not A or B. Not A or B. Notice this or is the logical or. It's the inclusive or, meaning it's not in A or in B, or both are satisfied. So first thing is you can get the not A, the complement of A. Notice that A has 4, 7, and 9. So I'm going to come here and take away the 4, the 7, and the 9. So the not A would be the 5, the 6, the 8, the 10. Right? We took away the 4, the 7, and the 9. Now, what is a not A or in B or in both? So I have the 4, I have the 5, I have the 6, I have the 8, the 9, the 10. 4, 5, 6, 8, 9, 10. 4, 5, 6, 8, 9, 10. It's C. Okay, the next one is similar. Number 17. That's page 4. Number 17 says, I have set A is 1, 3, 6. Set B is 1, 2, 6, 7. And the universal set, which we call omega usually, is 1 through 8. What is the intersection of the complement of A with B? Not A and B. So I can, like we did before, I can do the not A. The not A is everything here except that. So I have the 2, the 4, the 5, the 7, and the 8. Right? Everything from 1 to 8 except 1, 3, 6. And then what's both here and there? I can see the 2 and I can see the 7. It's only the 2 and the 7. I go here, 2, 7 is A. It's the first answer. Number 18. They give you a bunch of numbers and they ask you most nearly what is the random error associated with the lab measurement. the error is the standard deviation. Okay? So they tell you the concentration is 225, so you can use that as the mean, or you can simply enter these in your calculator and see what you get. So again, if I do that, $221, $229, $221, $227, $226, $223, $228, $223, $222, and $229. And then I quit, and then I do the stat, one variable.
Thank you.
You're welcome. It gives me the mean, which is 224.9 or 225, and it gives me the standard deviation of the population. It's 3.08. Notice, here they tell you the random error. Random error is usually for the whole population, not just for a sample. So it's 3.08, it's 3, it's 8.
Did they give us all of the formulas for like standard deviations?
I think yes. Yeah, you have a booklet
Yeah.
that has, yeah, it should be there. But you have to differentiate between the population and the sample. This is the important part. Problem 20. Oh, where is 19? That was 19. I'm sorry, that was 19, I missed 18. 18 says a given thermometer always measures temperature as being 2.5 degrees Celsius higher than the actual one. The thermometer is used to measure a water sample and find the temperature to be 25. The random error of the measurement is known to be 0. So there is no random error. Okay? Most nearly, what's the true temperature? Well, that's ridiculous. I mean, if it's 2.5, it always says 2.5 higher, so it's 25 minus 2.5, it's 22.5, so it's 83. That was ridiculous. Because the random error is 0. If there is a random error, you have to either add it or subtract it based on that. Number 20. Okay. They give you x's, y's, and y hat in a regression line, and they ask you if this is the true equation, most nearly what's the mean of the residuals? Is it tough? It's not tough at all. You don't need this equation at all. Because the residual is basically what you observe minus what your model is expecting or estimating. But they give you the estimates. So why would I multiply this by that and then add this? Because I know the answer is this. So really, what we have here is we have to calculate they tell you the linear model is that what's the mean of the residuals. So I'm going to add all the 3 residuals and divide them by 3. It's really so easy. What I observe is 2260. In fact, I can add all 3 and then subtract all 3, right? Because I'm going to say this minus that, plus this minus that, plus this minus that. So minus, and then I open parentheses, 2131 plus 4224 plus 8355. I got 0. So when I sum, the sum of the differences add up to 0. So if you divide it by 3, you'll get 0 anyway, right? So this is 0, and 0 is B. The last one we have, they give you a linear model, y equals a plus bx. They give you a, they give you b. And they say the observed dependent variable, meaning the y, has a value of 156.21. Y equals 156.21. At x equals 10. x equals 10? Most nearly, what is the model residual at x? So they give you A as 124, and they give you B as 1535. So x estimated would be A 1.24 plus B times x, which is 10, right? That's what you expect to get. But what you really got was 156.21. So you say 156.21 minus that is 147. 147 is D, not A. They want to know which one. You always say what you see minus what you expected is the residual. So x bar was 154.74, and the error or the residual is 147, which is D. Okay, sorry guys to keep you. If you have any questions, let me know. But please, you can go to homepage of, it's easier to go to www.rpi.edu/tilde and then my username. You will see, by tomorrow, today I don't have time, I have to pick my wife from work, so I have to run to Albany. Tomorrow, probably around 1 p.m., I will make a copy of these 4 pages and post them on, oops, I'm sorry. I post them here, and then what I'm going to do, as I said, I think you want to put here, in the same page, I have a Word file called IEA videos. When I was the coordinator for IEA a long time ago, I developed videos for all the lectures of IEA, broken into pieces. So you may go to lecture 13 and find 5 videos. The first one talks about 2D moment, explain it, and then an example, and then 2D moment using like vectors, and then another example. So I broke down each lecture. So if you or any freshman that you know that who needs it, I mean,
Yeah,
it's
that's helpful.
on media site. So you click on whatever. So I don't have it on laptop now, but so if you open the file, you'll see that it says, for example, lecture 13A, and that's 2D moment. Or lecture 17B.